Now, I want to mention real quickly before I move on to the next example that I know I only did a two-tailed example here. I did not do a left-tailed or a right-tailed, and they are slightly different. That's what the Excel videos will guide you through. I want to get you the main ideas here in the lectures, but I'm not going to lecture to you on every single type. So go look at the videos. It changes how you do, in particular, the critical values, and the p-values gets calculated slightly differently. Of course, if you're working in StatCrunch, then everything's a breeze, but StatCrunch doesn't find the critical values easily for you, but it'll do the p-value method no problem. All right, speaking of the p-value method, I want to talk about the difference between statistical and practical significance. So you can read through this example, and it's talking about how when you have a calculator or a computer and you tell it to choose randomly between 0 through 9, with each digit having the exact same chance of happening, it should be 0.10 per digit, which means you should have a mean of 4.5. So whenever you pull a sample of random numbers from Excel or from your calculator, if it's from the numbers 0 through 9, the average should be 4.5 or 4.5. So what we did was we had a computer do this. We had a computer or a calculator do it with 100 times. So you have the calculator choose 100 random numbers. Let me show you what that would look like. Oops, there you go. So I use the ran between function 0 through 9, and then I just have it choose it 100 times. So I drag down, that's 26 times, and then keep dragging. Drag, drag, drag to 100. There you go. So you have Excel do it right there. Okay, and then you have it do it again, but the next time you do it with 10,000. You get me? So let me go back. Whoa. I forget where I'm going. There it is. Okay, so we did it with 100 times, and we got a mean of 4.4, which is just a little bit off of the 4.5 we were expecting. And then the standard deviation is 2.9. That caused the standard error of the mean, i.e. sigma over the square root of n, what we learned in chapter 8.1, to be 0.29 and t to be negative 0.345, with the p-value of 0.731. So show how the standard error, and then the next time we did it with 10,000 draws. And the mean is still only 4.4, which is only 0.1 away. Standard deviation is 2.9, and so on. Okay, so the first thing they want us to notice is how the standard error and the test statistic values were obtained. So let's talk about the standard error. Standard error has a formula that you learned in 8.1. Namely that it's, oh, for the love of goodness, sigma, there we go, divided by the square root of n. This is the standard error of the mean. It's called sigma x bar. Oops, I lost one of my palettes. Hold on one sec. There it is. Okay, so it was 2.9 over the square root of 10 when n equals 10. So let me put it this way. N equals 100. It was 2.9 over the square root of 100, I'm sorry. The square root of 100, which is equal to 2.9 over 10, which made it 0.29. And then we have it again with n equals 10,000. That was 2.9 over the square root of 10,000. Which makes it 2.9 over 100, get it the hundredths place, right? Which puts it in 0.29. So check. This is 2.9. 2 is in the tenths place because you divided by 10. And this has got the 2 in the hundredths place because you divided by 100. See all those things you learn in school? They're coming back to you. Okay, so that's the standard error, right? Called the standard deviation and sampling distribution. And if that's the case, the test statistic gets calculated. Let me max this out here. The test statistic, which is T0, is equal to, and then it's the difference, which we know is 4.4 minus 4.5, which is only 0.1, right? They're only 0.1 apart. But instead of dividing it by divided by 0.29, right? Which gets you that number that they got, which was, oh, and this is negative, whoops. Because it's negative, right? 4.4 take away 4.9, which is negative 0.345. And there's the other one. It's the same thing, but it's 0.029, which makes it negative 3.45. Now, how did I know those numbers, you ask? Well, because they're right here in the table. They were given to you.